In this video, we are going to discuss about several object detection techniques. But before starting with that, we must know that what is an object detection. Object detection is nothing but a technique to detect objects like car, person, teddy bear, etc. using computer vision. Also, image processing in images and videos. Object detection models are more appropriate than image classification to identify multiple relevant objects in a single image. Like here you can see that it is marking a person, a lady sitting, that she's a person. The chair, it is also identifying as an object. The bed which is there, it is also identifying that as an object. So it is basically a technique to detect several objects using computer vision and image processing. Now, we must know for every processing or any kind of further functionalities, we need a data set. So we must know about the popular data sets which are there for object detection. So some of the popular data sets for object detection are Pascal, also known as Pascal VOC, that is Pascal Visual Object Classification. This dataset is mostly used for object detection, classification, and segmentation. That means separating the objects and so on. It has 10,000 images for both training and validation into 20 categories. So one thing to be noted that it has 10,000 images for both training and validation, and it is subdivided into 20 categories which is there. Another dataset is ImageNet. ImageNet has 5 lakh images for training, only with 2000 categories, but less used because of the huge dataset. And it is divided into 200 categories which is there, but it is less in use because it is a big data set and it is computationally intensive also. Next data set which is much in use is COCO dataset, Common in Context dataset. It is used for multiple challenges like caption generation. For example, if I want to generate the caption of that image, then I can write as a person sitting on chair. Such kind of caption can be also generated using COCO dataset, object detection, key point detection, and object segmentation also. The dataset changes every year but usually is composed of more than 1,20,000 images for training and validation and more than 40,000 images for testing within 80 categories. It is recently being split into test and train dataset to avoid the overfitting. Overfitting, you might have heard the word also, which we discussed in our videos where we were discussing about machine learning, that we do not give the whole set of data for training, otherwise the machine gets overfit. So it has been split into the test and train set of data to avoid the overfitting. Next, we are going to discuss about some object detection methods, how they are used, what are the benefits of using them, and what are the certain drawbacks. So the very first object detection method which we are going to discuss is hog features. In a groundbreaking paper in the history of computer vision, Navneet Dalal and Bill Triggs introduced the histogram of oriented gradients. Histogram of oriented gradients, that is hog features, in 2005. Hog features are computationally inexpensive and are good for many real-world problems also. But they have less accuracy though. That means they are computationally good but the accuracy is less. Next, we are going to discuss about RCNN. Hog was less accurate and CNN were computationally expensive but slow. RCNN solved this problem by using an object proposal algorithm that is called selective search. Also, which reduces the number of bounding boxes that are fed to a classifier close to 2000 regions proposal. That means 2000 regions of a particular images, the bounding boxes are made according to that. So what I have to do, run the selective search to generate the probable objects, feed these on the CNN followed by the SVM to predict the class of each path, and then optimize the patches by training and bounding box regression separately. The third object detection method we have is SSPNet, that is Spatial Pyramid Pooling. Now RCNN, we know that it is also slow, so we use the SSPNet on the top of it. We calculate the CNN representation for entire image Only once you can use to calculate the CNN representation for each patch by the selective search. But backpropagation is not possible in it. Backpropagation is not possible through the special pooling layer. So then we come to the fast RCNN. Now what is in fast RCNN? They made it possible to train end-to-end, to propagate the gradients through the special pooling. It uses a simple backpropagation calculation which is similar to max pool gradient calculation also. It also added the bounding box regression to the neural network training itself. Another variant of it which is most used is faster RCNN. In faster RCNN, it replaces the selective search. So now the selective search is cancelled in the faster RCNN. It is cancelled, and also a very small convolutional network called the region proposal network to generate the region of interest. Faster RCNN is 10 times faster than the fast RCNN, which is similar accuracy like the dataset like the VOC 1007. That's why faster RCNN has been most accurate in the object detection algorithm. Next we come to YOLO. You only look once. It's a simple regression problem which takes an input image, learns the class probability, and then bounding box coordinate. It is a single shoot detector. Which detects the image in a single scan, hence it is faster also, but it struggles with small object. As it is a single shoot detector, sometimes it misses the small objects which are there, but it is good because it is fast and it does the detection in a single scan. Next we have SSD. SSD, single shoot detector, it gives good balance between the accuracy and the speed. SSD runs a convolutional network on input image, and once it calculates the feature map, it better works on the larger object also as compared to the RCNN, or we can say the faster RCNN also. And the last object detection method is mask RCNN. Mask RCNN, it extends the faster RCNN, we can say another variant of it, by adding a branch of predictive and object mask in parallel with the existing branch. It computationally extensive and scans a single image many times, which makes it slow but accurate also. That means it scans the single image many times to be accurate, but it automatically slows down its processes. So by the end of this video, we have discussed about several object detecting methods also, the popular data sets for object detection which are in use, and what do we mean by object detection also. For the notes, you can refer to our official website and the link will be given to you in the video description.